Okay, welcome back. This is part two of our screencast. Hopefully it'll be part two, and hopefully I will not mess up the editing like I did last time. I'm going to just explain what I have so far to catch you up. But basically I'm working on PA1. It's two-thirds done or three-quarters done. And I have built it using what we call test-driven development, which we haven't talked about in class yet. But it's pretty straightforward. It means that we write tests for the functionality we want before we actually write the functionality. Now, I have it all in one file just to make it easier. Normally I would have two files, one for the program and one for the test cases. Furthermore, normally I would have actually a separate file for every class. In this case, I put them all in one file, and I actually have three classes. I have a user class, a movie class, and a movie data class. And then starting here, it's all test cases. All right. So basically, the notion is that a test case is what is run when you want to know if the program is working correctly. So I'm going to just run this test case and show you what happens to remind you. So basically, I get a little dot for every case that runs. And so if we look through the test cases, you'll see, I'm going to hide this again, all the dots mean that all the tests worked. Okay? So the structure of a test case is generally this. There's a describe block, and by the way, there's many different test unit test frameworks. The one we're using is called mini test spec, which is a variation which we're going to use. I haven't used it before, to be honest, but I wanted to learn it, and it looks pretty good to me. It's built into Ruby, so it's there without installing anything extra. The structure of such a test case is essentially a describe block, which is intended to describe the behavior of a certain class. In this case, it's the movie data class. It's just documentation, and it says before you run any test, do this setup between before and end. So before you run any test, and then every single test is preceded by an it keyword, and meant to read a little bit like bad English. So this test is meant to verify that, in fact, i.e. movie data, can be constructed. And it's pretty simple. I do a standard Ruby statement which says movie data.new, assign it to a variable A, and then I verify that A is not nil. Okay, that means that it worked. Pretty simple, but when you first start to code, you sometimes have little errors in very simple things. It does test the minimum case. The second thing I wanted to test was that it can actually accept a set of test data. One difference that in the way I've implemented it compared to what you probably did in your homework is that I did not build in the testing of the big file immediately into the program. And the reason for this is that generally when you put a whole big test case or a big bunch of data into a program, it's very difficult to tell whether or not, or if the program doesn't, if it crashes, you can tell it crashes, but if it works, but it gives an answer, it's 2 and 5 instead of 3 and 4, it's kind of hard to be sure you got the right answers. So the right way to go around this is to shrink the test case as small as possible. And the way we do that is by decoupling the test data from most of the program. So the way I did that in my movie data class is I wrote a method in my movie data class called, where is it? Accept rows. And the spec for accept rows, or the idea with accept rows, is they would receive an array of arrays. The top level array is meant to represent each line in the test file, if there was a test file, and the embedded array corresponds to each element of the line. So it corresponds exactly to a row, to the user ID, the movie ID, the rating, and the timestamp. But by separating it from it, I can now work with much smaller bits of data. So accept rows, all rows, simply takes the array of arrays, iterates over all of them, and calls the accept row singular method on the information in that row. And the accept row singular method now goes through and creates a user object, creates a movie object, counts the votes, and then finally tells the user object that was created over here that we know that this user rated movie MOV with rating. Okay, so this except row is called once for every single row in the input data, which is coming from an array, not even from the file yet. So if we refer back to the code, we see that the second test says, can I accept rows stored in the variable test1, the instance variable test1? If we look at test1, we see that there's just 2 rows worth of data, 2 ratings by the same user of different movies, and all we want to find out is that this thing happens without crashing. Now we can actually go a little bit further. We can say, for example, that we assume that as a result of this, user count must equal, and we think 1. Okay, so it accepts the data, and from the array, and then it verifies that I have only 1 user. Why? Because the test data says that both ratings were from the same user. Okay, so it's testing something very elementary, but that's how test-driven design goes. You just build up, build up, build up, build up, and you'll have confidence at every stage that it's correct. Okay, so the next test is testing except row, not plural, but singular, with 2 different ratings, both from the same user. Again, it should equal to 1. Next thing, I'm going to verify that MD1, notice I'm now talking about a different movie data object, which is again different from what you probably did in your homework. I realized that there's no reason to have a single movie data object. In fact, I created several test instances of that, which with different data built into them. So if we go back to the before, you'll see here that MD1 is another movie data object. This time, I immediately give it the test data, and I ask it to accept that row. So now MD1 is built in, always available to use. So I'm going to just check that the popularity list must equal 2. And if we refer to what the popularity list is, it's simply the list of all the movies ordered by popularity. And since our test data number 2 looks at 2 different movies, movie 1 and movie 2, I would expect it to have 2. So far, so good? Okay, let's look at the next example. Now I'm going to look at popularity list in more detail. I'm going to ask MD2 to give me the popularity list, and I would expect that movie number 1, the most popular movie would be movie number 1, and the second most popular would be movie number 2. Why is that? Well, because if I look at the data that I'm using, I see that in MD2, I have 2 ratings for movie number 1 and just 1 rating for movie number 2. Okay, so very, very simple. But again, that test checks that very, very simple question. Next, I'm going to check for similarity. So this is tricky. I'm going to start by checking with MD2 the similarity between 1 and 2. And all I say is it's got to be greater or equal to 0 and less than 100. You know, and that seems like a pretty vanilla assumption, since that's our rule is that similarities between 0 are between 0 and 100. And I wrote this before I had any idea of how similarity would work. I just wanted to make sure that it was working between the range that I expected. Now, the next question I had was, does my movie data class or instance properly keep track of the movies that an individual person has rated? So now I go to MD3, which is movie data number 3, the third set of data, which is a little bit more complicated. Here it is. I'll come back to it once we understand what we're testing. And we see here that I want to know, first of all, I want to get the user 3 object, and then I want to ask user 3 how many movies he rated, and it should equal to 3. So if we look over here, we see that sorry to go back and forth. We're talking about user 3. User 3 has rated, in fact, 3 movies. That's correct. So that's what I would have expected. It's interesting. I didn't check the case of when user 3 rates the same movie more than once. That would be a case. First, we'd have to decide on the policy. Is that permitted? Yes, I think it's permitted, and they both should be recorded. So I can quickly write a test case for that, can't I? Um, um, I might do something like this. It handles the case of the same user rating the same movie. Do. And I'm going to again grab user 3. This time I'm going to look at my code for the user, and I'm going to see that user has a command rated, which allows me to indicate that I've rated this movie again, right? So if I say in the one I'm just writing now, which is this one, user 3 rated, and now what movie? I want to pick the movie that he's rated already, let's say movie 1, rated, where am I? Here, movie 1 with a 5, okay? I can put the parentheses to make it more legible if you want, but it's the same thing. And I should now see that movie is rated for user 3 in length must equal 4. If this works, it means that I properly have accepted another movie with another rating from the same user for the same movie. I can run my tests, and because I have only dots, it tells me that all the tests worked correctly. Isn't that cool? Very quickly, I can now keep on. It's kind of like doing kind of a proof or a set of assertions. Anyway, so that's the essence of how the unit testing works. Let me just look at the code and show you a couple of interesting things. The similarity was the most tricky and the most interesting. So essentially what I'm doing is, now why do I use find or create user? Let me start with that, because when I call a similarity, what I'm giving it is two user IDs, not user objects. It's easy to get those two things confused, two user IDs, okay? And the reason I say find or create user is if I ask for if I give a user ID that does not exist yet, I will get a brand new initialized user. So I get U1 and U2 now point to legitimate users, and now I'm going to get as a set, and here this gets interesting. Movies rated is a set. If you look back here, you will see that I'm requiring the standard library called set, and if you look over here, you see that I am initializing it with a new set. So every time I do this double angle bracket, I'm not adding a movie to an array, I'm adding it to a set. Which is pretty interesting, because that would imply, if that worked correctly, that in fact I should not have successfully noticed that the set was larger, because I was reviewing a movie that was already rated once. This data structure to me is incorrect now, because if I rate the same movie twice, I'm not going to add to the set, so the length of movies rated should not grow. So query, why did this test pass? Let's go look. I rated movie 1, which I had already rated, and the movies rated grew. That's very strange. I would have expected the movies rated class to have not grown, so that instead of being 3, instead of being 4, it would have still been 3, and this test would have failed. Okay, very interesting. Let's go back and look at the code and see if we can see what's going wrong. So movies rated is an accessor. Movies rated is a set new. Every time I get a new movie, I'm adding it. When I rate a movie, I'm just giving a number, which means that at this point, the movies rated should be a set of 3 things. So now I'm going to jump to put in some printing. Normally I would jump into a debugger, but in this context it's kind of hard to demonstrate while doing the screencast. So what I'm going to do is I'm going to write at this spot, I'm going to do a put s, right in the test, just fine, it's just Ruby code. Put a bunch of stars so I can find it inside of inside of the other output that may be coming out, and I'm going to go u3.moviesrated .inspect, which gives me a nicer dump, sort of a programmer's dump of this particular set. So I'm going to run my tests, and I'm going to, aha, I see what's going on here. So, no, I don't see what's going on here. I see the set of 1 movie, 2 movies, 3 movies. Um, and the number 1. Oh, wow. So here's what happened. The set was built up from movie objects, but I incorrectly um, added a number, which is just a movie ID, which is, of course, a big fail. Okay? So the question is, could it have been detected? Do you want to put error checking? You might want to put error checking. So the way I would do that is, for example, I would go over here and I would say raise runtime error can only rate no movie object expected, and here's a trick: unless movie.class equals movie. Now, if I did my job right, this is going to throw an error when I run the test again. And nope, not quite, because I have a typo in here. I try it again. And this time, movie object expected. Okay, so now it's throwing an error, which would have caught my error, my incorrect call to this method over here. And I'm going to fix this method over here. And the way I'm going to fix it is, instead of rating 5, movie 1 rather, I'm going to do this. I'm going to go find or create movie 1. Of course, that's a method that has to be called relative to a certain movie data instance. Now I'm going to try to rate it. I'm not going to get that error, but I'm going to get a different error. And the different error is that it expected 4 movies in the set. It only got 3. Why is that? Because the set of rated movies will not allow me to store the same movie twice. Now we're at an interesting point to decide whether or not this is what we want. The question goes like this. Does the user object collect every rating individually or every movie that was rated? That's the question. For now, I'm going to just change the semantics of the expected semantics, which, by the way, are encoded in the test in a way. And the way I change the expected semantics is I'm going to say that even when the user rates the same movie again, it does not add a movies rated to the set within the user record. And so it becomes 3 again. And I'll just add a comment, because rating the same movie twice does not add a record, a movie rating to user. Now that we may live to regret that later, but for now it's fine. Run my test, they're all working. I think I'm going to stop here. I'm going to try publishing this and get your feedback as to whether this continues to be useful. I'm having fun. Okay? And also I want to hear whether the size is right and whether you can follow it along and so on. Okay? Thanks very much, and talk to you soon.